All right, welcome everybody. You've just turned in homework number 5, which is the present worth assignment, right? The next one that you have, I've deliberately kept kind of short. There's only 3 problems in homework number 6, and that is so that you have a little bit of extra time to review for the exam. We have an exam coming up next week. It's going to be on Wednesday. The exam's going to include some concept questions and some problem-solving questions. Now, most of it will be problem-solving, but I will ask a couple of concept questions just to kind of see if you can do more than plug the numbers into the equations. It's oftentimes, like in terms of retention, what you remember a lot longer than which formula to use or the definition of different variables in an equation. What you tend to remember over the longer term is the concepts and the underlying ideas. And so I'm hoping that you're able to do both. Explain things and understand why we do an approach a certain way, and then also use that approach to make decisions. Okay, so today we're going to be talking about future worth analysis, and it's very similar to the idea that's behind present worth analysis. In present worth analysis, you had a certain decision criteria that you were applying. What we did was we applied the present worth method, which is where you're taking all future cash flows to year 0 in the present worth method. And then that extra step that turned the present worth method into present worth analysis was comparing alternatives and making a decision. And so the alternatives that we compared when it was the LCM method or contract services or early termination, what we were doing with those techniques were making it so each alternative had the same study period. And then once they had the same study period, we could compare them on an equal footing. So why do we do present worth analysis? This is just an illustration of some of the concept questions that you might get during a test, just so it's not so unfamiliar. We haven't done a lot of concept questions in the in-class exercises or on the homework assignments. So here's a few just to whet your appetite. So what's the purpose? Anyone want to take a stab at that one? Why do we apply that present worth analysis? Yeah?
To compare, like, if you paid for all of it now,
Uh-huh.
what the price would be relative to
Good.
other options.
Good. Yeah, so the purpose is to account for the time value of money. The fact that amounts in the future won't be as valuable as amounts today. And so this analysis takes that effect into account. All right, here's one. LCM. First of all, what does it stand for? Least common multiples. Good. Now, sometimes in a question like this, a student would see something they know, so they'd see LCM. And so someone might answer to this question, LCM stands for least common multiples. And that's a true statement, but it doesn't answer the question. So don't fall into that trap of answering the wrong question. Because here I don't ask what LCM stands for. I'm asking what assumption is built in. So what is the assumption when we are repeating the cash flow diagrams? What are we assuming?
Repeatability.
Repeatability, that's right. And so we're assuming that the item can be purchased again in the future and generate the same revenues in the future as it did during the first cycle. So that's kind of the inherent assumption that's baked into the LCM approach. Okay. Now what about this acronym, MARR? Well, it stands for minimum attractive rate of return, but that's not what this is asking. So don't fall into that trap of answering the wrong question. What factors influence MAR? And so why would a company choose 12% for their MAR versus 3% for their MAR? There's a variety of factors. Does anybody remember what some of those are?
Risk.
Risk? What do you mean?
Like, if a company is like giving out a loan
Okay.
the higher amount the loan is,
All right.
the more risk there's going to be that the person that's receiving the loan isn't going to pay it back.
Okay. Yeah, so you're remembering a really important point, and that is a lender evaluates the risk of the borrower, and that risk can dictate the borrowing costs. But what if you're the one who's borrowing money? So in that case, your borrowing costs is what affects the MAR. And that's probably the single greatest factor of, if I'm running a company and I want to do a certain project, how much I have to pay to the bank to get the money to do the project is going to be like the ground floor of what I accept as a minimum rate of return. But that's only one of the factors. The other factors could be, and there's a list of them in the notes, like the variety of projects that are available. If you have a lot of options of really attractive projects, then it wouldn't just be the borrowing costs that you set at your MAR. Your threshold for returns might be higher. It could be the type of organization, and what the notes say in the textbook is that for-profit companies would generally have a higher rate of return expectations than a non-profit organization. So hospitals that are owned by a charitable organization may have a lower MAR on a project than, say, a big for-profit company like Google or Facebook. All right, this takes us back a couple of weeks. Why is there sometimes a difference between the nominal interest rate and the effective interest rate? And so just as an example of how sometimes answer the wrong question, when I have put this question on an exam, I one time had a student just write the equation for the effective interest rate. And I was really impressed that they had that equation memorized because I hadn't provided it, but that's not the answer to the question. So the question is, how come sometimes nominal and effective interest rate aren't the same? What is effective interest rate? Go ahead.
Effective is the true interest rate over a year.
Okay.
Nominal is what it would be if you added them up by day, month, week, throughout a year.
Good.
The nominal interest rate accounts for periods.
Good. The number of periods per year, yeah, and the effective compounding. So the nominal interest rate doesn't take the compounding effect into account, where, and by that what I mean is you're paying interest on top of the interest. And so nominal just kind of adds the interest rate for each period in a year together, and there might be 4 periods in a year if it's quarterly compounding, or if it's monthly compounding, then there would be 12 periods during the year. So the effective interest rate takes that all into account. Okay, now here's just a review of our 3 different approaches for making the study period the same. If the study period doesn't have the same duration, then we can use the least common multiple approach, contract services, which is where we're extending one of the cash flow diagrams by leasing the equipment, or early termination, where we're making one of the cash flow diagrams shorter. And remember that the length of this green arrow in that in-class exercise wasn't the present value of this annual that was being lost, it was the salvage value. So it's how much you can sell the equipment for. It's not the value of the revenue that's foregone. Because that would just be the same as taking all the revenues to the present. When really what you're doing is you're selling the equipment early. So those are our same 3 techniques that we can use in future worth analysis. If we have a situation where the cash flow diagrams are a different length, and what we want to know is the future equivalent of those cash flow diagrams to compare, then we can still use LCM, we can still use early termination, we can still use contract services. The idea with future worth analysis is just that we're going to take the cash flow diagrams to some certain date in the future rather than to year 0. When would you use future worth analysis instead of present worth analysis? Well, there are some projects where they are very long in duration, where it's more than just buying a piece of equipment. It might be that in the case of building a dam, for example, or building a toll road, there's some year after year of construction, and so then the contractor is turning it over to the client. Now the builder has been spending money over certain years, and they want to know, now that I'm finally ready to turn the project over to the client, what should my payment be? And so you're wanting to know the future value rather than the present value, because you've had all of these expenses up until the point of sale. So that's one big illustration of when you'd use the future worth analysis, is when a project is going to be sold before the end of its useful life, or if it took many years to construct. So here's our decision criteria. There was a similar slide to this with present worth analysis, and I've just changed a couple of words. So it says when cash flows are compounded to a certain future time at the MAR. So this first part is just a summary of what the future worth method is. But then the analysis is comparing two options. And what we do is we choose the alternative that has the highest non-negative future worth. Now the difference is that first slide, if I jump back to that briefly, when we were comparing the decision criteria for the present worth analysis, okay, this said when cash flows are discounted to the present. So remember, discounting is when you're moving money backwards through time and the amounts get smaller. Compounding is when you're moving money forwards in time. So our decision criteria is just a summary of the method. First of all, you're moving the money future in time. The amounts are going to be getting larger because of the inflation effect. You use the MAR as the interest rate. And then it says here, to a certain future time. It may be that you're moving it to year 10. It may be that you're moving it to year 20. It's context dependent. It's not always going to be a fixed time. It may depend on what your other alternatives are, which date you move it to. So you sometimes have to look at the individual problem to have a clue of what year you need to do the compounding to. All right, so here is our in-class exercise problem. The front side of the paper asks us to consider two options for rebuilding a shipping channel. One of the options is a long-term approach of completely rebuilding the shipping channel. The other is more temporary. And you can see the temporary option doesn't last as long. And since these two options have a different length, what you'll have to do is account for the different study period by making it the same. Now it says here to use Microsoft Excel. So remember, the function for finding amounts in the future is the future value function. It's been a little while since we used the future value function. So to trigger it, you do equals FV, comma, and then it'll start to give you the clues like NPER, interest rate, whether you want the amount that you're putting in to be considered as a payment, like a recurring payment, or whether it's a present value, and so on. And there's an extra column that we put in when we're using Excel for the future value method. Do you remember what that extra column is? Go ahead.
The years until.
Years until. That's right. So it's a secondary time column. So we're going to have years. We're going to have years until, and in this case we want to take everything to year 9, amount, and then FV of amount. And then up top you'll have a interest rate indicator, and that's how you should set it up.
Have to wait. With regards to.
Sometimes it can be useful to draw on the paper when you're going to buy the item again. And so let's look at option B. We have to do option B 3 times to get through the full 9-year cycle. So if we want the channel to be clear continually, we do the dredging at 0, then it's clear for 1, 2, 3 years. So if we want it to stay clear, we have to dredge again at 3. So we're going to dredge at 3 and at 6. We won't dredge at 9 because then the period would extend too long. So you'll notice here for my option B, I've got our initial purchase of $225 million in year 0, and then in year 3, there's both the redredging cost and also the revenue from that year's operations. So the net value of $190 million outflow is the dredging cost and the revenue just from that year. Now, how do we make the decision? You have to add it all up, so the sum of the future values, which means, how much would you have to receive in year 9 to make this entire thing worthwhile? If you were a contractor and the government was paying you to keep this shipping channel open, then what you need to tell them is you need a lump sum in the amount of, if you're doing option B, $607 million in year 9 in order to make it all balance out at 7% interest. Okay, on the second part of the in-class exercise on the back side of the paper, when you get ready for that one, I ask you to begin with a cash flow diagram, because translating the word problem directly to a cash flow table sometimes is too much of a leap. So it's better to, first of all, put it down as a cash flow sketch on the paper and then turn it into a diagram for both option A and option B. Yep. That's right, good. So the question is, how much should the uncle pay in order for it to be equal? And so the option A has a value of $51,000, and option B would be great. If you could get this $25,000 a year by only paying $1,000 up front, you'd be doing great. But what we want to know is how much can he pay and have the same equivalent value in future terms. And so in order to do that, we could keep manually adjusting it. So we could put in a different value, like maybe it's 10,000. That's not quite there. Well, what about 100,000? What about 1,000,000? That'd be way too low. So the easy way to do it is data, what if analysis, goal seek, and then our objective is that we want this, which is the sum of the future values, should be the same 51,045.64 that we saw as the sum of option A future values. And then we're telling it that it can change the amount that is in this cell, which is the initial purchase price for option B. So as soon as I click OK, it's going to keep changing around a bunch of different values in this cell, and it's going to be looking at G17, the sum of the future value of the amounts for option B, and it'll stop when it finally finds the input value, the purchase price, that's equal so that the cash flow diagram is the same. The future values of option A and option B are equal. So the answer for the second part of the question, how much should your uncle pay? Your uncle should pay $181,769. All right, so it's Friday. I hope you have a good weekend. Remember that the next homework assignment's available now. That homework number 6, future worth and annual worth. There's only 3 questions, but you can solve the first one at least. So I'd encourage you to take an early look at it.